Welcome to the Babbage Theatre. And as part of the Cambridge Festival, tonight's topic, climate repair, hope or hype. So climate repair is obviously another and in theory more accessible word or phrase, I should say, to describe geoengineering. And in a sense, what's that? Well, I done a few programs on this, and as someone sort of eloquently put it, it's about, okay, we seem unable to not make the mess, so climate repair is about cleaning up the mess. So I think that's quite a sort of accessible way of putting it. In effect, that's referring to a lot of techniques, some natural, some engineering-based, some marine-based, some land-based, some air-based, some atmospheric-based, some almost societal-based, that might help us reduce the rate or possibly reduce the absolute level of climate change. And it is, of course, a very controversial area, because to some it is an excuse. It is an excuse to get away from the fundamental need, which is to reduce the emissions of the greenhouse gases in the first place. If you have a fix, do you bother with the cause? On the other hand, many people say climate change is such a massive threat, we can leave no stone unturned, even if some of those stones seem pretty, let's call them, outlandish. Anyway, we do have a most excellent panel who you'll hear from in a wee moment, but I just need to go through some of the housekeeping here, which is that we are not expecting a fire drill of any kind tonight. The fire exits are there, and there's one there. And if you do leave the building, you're then to gather on the Downing site, which is apparently on the other side of Downing Street. That's the one in Cambridge. The loos are all up the back. I think it's gents on that side, ladies on that side, disabled on this side as well. And I should say that this event is being filmed but not live streamed for use on the YouTube channel, and maybe some clips, I guess, to be used possibly by Cambridge University or Climate Repair Centre. The camera is facing this way, so it's not going to come around and look this way. So on the whole, the audience won't be identifiable. Some of you may well be identifiable by the back of your head, but if you're not worried about it, I need to let you know. But that's I think all the red tape out of the way. So the way this is going to work is we're going to hear first from Sean Fitzgerald, who is director of the Centre for Climate Repair, and I can say from having had him on various programs, a most fine and thoughtful speaker about the challenges and opportunities in this space. So Sean's going to give a little introduction to the topic, and then I'm going to come back and introduce the panel, and we'll get stuck in. So, but for the moment, Sean Fitzgerald, please.
Well, great. Good evening, everybody. So I thought I'd just spend no more than 5 minutes just covering a few topics. So the first issue is, well, where we are today. And you'll all be aware that climate change is something that is happening. 2024 was the first year where we saw a 12-month period where the average was at least 1.5 degrees centigrade, and that has consequences. If we now think about the Paris Agreement, which was to do everything that we could possibly do to keep below 1.5 degrees, and certainly below 2.5 degrees by 2100, and this is now obviously 2024 when the announcement was that we're at 1.5 degrees. And the consequences are, for example, flooding events, severe weather events, and the increased frequency, increased severity of such, and of course fires. This picture here on the fire was in British Columbia, but actually you might have remembered the story of Lytton. That photograph is actually 2 years later. So although it was unprecedented at the time, 2 years later they were suffering the same sort of events. So that's where we are. We're not going somewhere very pretty. So if you go and look at the IPCC reports, the most recent one is AR6, which is just suggesting that temperatures are continuing to rise, and the most ambitious scenario involving greenhouse gas emissions reduction coupled with greenhouse gas removal does dip below 1.5 degrees centigrade by the end of the century. But the reality is that we're not following that trajectory today. So what we mean by climate repair is going beyond the measures considered currently by the IPCC in their scenarios. So aggressive emissions reduction coupled with what we call greenhouse gas removal. Elsewhere in the world, you might have heard the term carbon dioxide removal. The reason why we use the term greenhouse gas removal is that there are some other greenhouse gases other than carbon dioxide, which we possibly could go at. And if we start to make an impact on that, it's going to, this is the purple line here, is the cutting emissions. That light blue line is removing carbon from the atmosphere. And you'll see that that's actually getting us to where we want to get to. But we're still going through this rather horrible hump in the intervening period on temperatures. And therefore, what we therefore consider is worth looking at are options to try and reflect more of the radiation from the sun away from the Earth during that period to try and keep temperatures at bay. So I'm just going to give you a couple of examples of what these could look like. This is a project where they are growing kelp in a place where it would not normally grow. So that's why we consider this as actually more of an interventionist approach. Yes, restoring kelp beds around the coast is great. We should be doing that for lots of reasons, ecosystems, but should we also be looking at things like kelp and growing those on farms in places, for example, deep water where kelp wouldn't normally grow? Do you provide rafts? Do you provide buoys onto which the kelp can grow in order to do that additional carbon dioxide sequestration, and bits of kelp then slough off and go into the deep ocean? These are question marks. So this is a project actually which is undergoing in the Faroe Isles with one of our PhD students monitoring and modelling that. The third area, which is the trying to make the Earth more reflective, the picture on the right is actually a live experiment that's been ongoing over the Great Barrier Reef. The Great Barrier Reef is suffering from coral bleaching as a result of the intense radiation and the temperatures. And one idea has been to see whether we can actually create some brighter clouds over the ocean. And if those of you who have been familiar with things like ship tracks, as a result of the 2020 regulation change with the International Maritime Organization, which was causing desulfurization of bunker fuel for health reasons. So health impacts, it's good to clean up the fuel, but the consequence of that, which is borne out by various literature, is that the clouds are not forming as readily over the ocean, and therefore actually the ocean is warming up. Well, can we think about producing not more sulfur from the ships again, but natural aerosols? And those natural aerosols are in the form of nothing more than sea spray being generated. For example, this boat here, which is sucking up some seawater, generating a sea spray. The droplets evaporate. They leave behind crystals of sodium chloride, which then get convected up into the marine boundary layer and might act as additional cloud condensation nuclei to provide brighter clouds. So that's an example. And the example on the left is actually looking at whether we can keep the Arctic a bit more reflective. And this is using technology, I hate to say it, but stolen and borrowed from the oil industry, where they make ice roads by pumping seawater on top of existing sea ice to strengthen that. Well, I don't like oil coming from the Arctic and things like this, but actually should we just, rather than shunning them completely, are there some lessons to be learned about, can we make the ice a bit thicker, grow it thicker over the winter so it might last longer over the summer? And I put this as a question because it is a research question. We do not know the answers yet. Initial results might be encouraging, but we don't know. So these are some of the sorts of things that we're looking at. And so those emissions reduction, greenhouse gas removal, and additional reflectivity is what we mean by climate repair. And it does carry some challenges because we don't want it to be, for example, a distraction on getting off the black gold in the first place. Is this going to just weaken society's resolve? So there are big issues here. And the United Kingdom, as a result of the funding agency ARIA, that's the Advanced Research and Invention Agency, we're now the largest funded country with government funding for research in this kind of area in the world. So it's raising lots of questions, and hence the topic for this evening of hope or hype. And with that, I'm going to hand back over to Tom. Thank you.
Thank you very much indeed, Sean. That was most excellent. I would also add to that, it's quite a broad range when you start looking at geoengineering. A lot of people would include, tree planting in it, certainly in additional, very determined tree planting, if you like. Other things to do with ocean seeding to encourage more photosynthesis, or maybe other forms of take-up. There's enhanced rock weathering, spreading rock dust around, and just quite a few, and then some very ambitious things involving the upper atmosphere, some of which have had a lot of funding lately. So it is a broad spectrum. However, we do want to, despite the fact that it's complicated, we want you to answer a simple question. So there is a Slido question hiding behind this QR code here. So this is the moment, the one of 2 or 3 moments, you'll be able to get your phone out, please, and have a look at that, which will basically ask the question, hope or hype. Have I got that right? There you go. So there you've got the Q, you've got the code, and the 3 options. Please don't all tick too soon to know, that would be really quite boring. But what influence I've had. So I'm going to give you, while you're doing that, I'll just bring the panel to the stage, please. If you could come up, and then while people are having a moment to enter their Slido things, if I could get the panel to come up to the stage, that would be grand. And then hopefully we're going to look at those. We're going to look at those figures. I'm going to remember them, or probably write them down, and then we might ask you again at the end to see if the views have changed at all by the end of your hour or so of listening to these fine folk. I'm just going to leave you a couple more moments. How's everyone doing? Are people mostly sorted? Navigated the tech? Still going a bit up and down? Well, there we go. I think I'm gonna pause it there. So what have we got? Hope 49. Is that still 48? It's gone down since I last looked round. Too soon. 27. Hype 24. Okay. Perfect. Okay. Very good. Well, thanks very much for helping out with that. And we're going to come on to the meat of the event now. The way this is going to work is there'll be a sort of panel chat between ourselves on the stage here. And then there'll be questions towards the end from the audience. If there's a particular point of clarification as we're going along, do kind of in that first chunk, do sort of put your hand up if there's just something that really isn't clear and or to you, and you'd just like it spelled out, then do put your hand up there. But for the real inquisitive stuff, if we can leave that towards the end, that'd be absolutely great. So the panel are going to do some sort of introduction of themselves, but I'm just going to help us out here. So at the far end, we have Amanda Burson from British Antarctic Survey, BAS, just up the road here in Cambridge, who is leading a government-funded project on the impact, or the ecological impact that particular types of geoengineering might have. Then we have Clara Botto, who is from the Centre for Climate Repair, who is bringing the questions of climate justice into geoengineering. Then we have Jack Stilgo, who's from University College London, and also from NERC, the Natural Environment Research Council, looking at the governance and funding of this. And nearest to me on this end, we have Oliver Morton from The Economist, who's also an author of a fine book called Planet Remade. So while I just wander to my seat at the other end here, I'm just going to try and pin you to the question that we asked the audience to answer. Hope or hype? Amanda?
Of course, I'm not going to answer that directly. So my answer to that would be worthy of investigation, for sure, but with a critical eye. So obviously I'm coming at it from potential ecological impacts, unforeseen or otherwise. So that's the position at BAS, and with our project, we really want to understand those potential ecological impacts. Are they minimal? Are they high? You should understand that before you
don't shut the door.
Go forward, but don't shut the door.
Right.
Get the evidence first before you make that decision.
Okay, and Clara?
I would be the one answering too soon to know probably, but no, just kidding. I personally don't think either represent what I feel. I would hope to feel hope, but I'm not there yet. But I also don't think it's a hype topic yet, at least in the climate space. It's still on the margins.
Yeah, Jack.
So I'm a social scientist. Social scientists always reject the question. In this case, the hope and the hype are definitely bound together. The hype is complicated because almost nobody in this world is just excited about the potential for fixing the climate technologically, right? So it's not just that. Just let me get on and do it. But there are flavors of hype that I think we should acknowledge. I can talk about some of those a bit later, maybe.
Sure, we'll hear about. And Oliver, what do you think?
I wasn't actually quite sure what Jack thought, but that doesn't.
Good, wasn't it?
Yeah, very nice, very nice. Politicians also avoid the question.
Yeah.
Journalists, of course, are honest truth seekers, and I also want to avoid the question. I think there is some hope. I think there's not as much hype as people might want to say, because simply on the basis that, by and large, the subject is still very, very little discussed. For my own personal position, I come closer to duty. I know something about this. I think it's important that people who do know something about this try and think through and do stuff to help to have a real discussion about it.
So a duty to do it, or a duty to illuminate it?
A duty to illuminate it.
Right. Okay, well, we're going to sort of try and slightly split up the discussion into different territories, all of which bleed into each other up to a point, so that becomes quite tricky. But I want to start with the sort of a few more examples of the kind of things we're talking about. The sort of doability of these things, the sort of practicality of them. So just for the sake of fun and reversing it a bit, Oliver, what do you think about, what are the most doable? What are the ones that you think are really sort of plausible in this space when it comes to climate repair?
Well, I think you have to judge both doability and impact. We know that it's really easy to plant a tree. I mean, I assume it is. I have planted a tree. So yes, it is easy to plant a tree.
To make sure it survives. That's a lot of things.
Yes, indeed. I planted my tree as a protest against a development that went on without any care in the world and uprooted the tree. So
I believe the A14 here is a good example of tree planting, but not survival. But...
Right. Well, there we go. But you can plant. The number of trees that you have to plant to actually get rid of the carbon dioxide is just vaster than anywhere where there's land which people do not have prior claims on, both property claims and indigenous rights claims. So that's doable in the sense that we know how to plant trees, but not doable in the sense that it makes a dent. At the other end, and the area where I spend most of my time thinking about this subject, would be solar geoengineering, so reflecting away sunlight. Now, to do that on a large scale involves technologies that we imagine are quite plausible, such as spreading out aerosols from aircraft, but we do not fully understand either the direct physical effects, the chemical effects, the biological effects, the political effects, the economic effect. We don't understand what that would do. So doable sort of like suggests, well, technologically, yes, I think it's doable, but that doesn't, just because something's doable doesn't mean it's doable technologically, doesn't mean it's doable by a recognizable group of people in society.
I think it's worth, when we talk about this spreading of aerosols in the upper atmosphere, there are various companies, I'm sure one of which we'll come on to later, but the reason people think this is plausible, up to a point, is because that's what volcanoes have done in the past. They've spread dust or particles out of the atmosphere that have had a noticeable impact. I think it's Mount Pinatubo in the 90s actually lowered the temperature of the Earth by, is it half a degree for a year? So there are noticeable impacts of that. Obviously, a volcano is a lot bigger than an airplane.
Could I just add to that? We've all grown up using this example of Pinatubo, and it's a very good example. It's the first time a prediction made by a climate model was proved out. So in a sense, it's basic to the whole science of climate change. But much more tellingly and recently, we see clear evidence that reduced human routine production of aerosols in the lower atmosphere, by reducing that, we have increased the temperature.
Aerosol, I mean,
Aerosol,
Sean mentioned
aerosol just means a
ships
little
and things.
thing that floats in the air.
But so Sean mentioned those coming from ships and things, the dirtier
Ships,
fuel.
but also all sorts of, and so, you know, sort of like China, if any of you went to China in the early 2010s, especially in this sort of time of year, you will have seen how terrible the air quality was. It's now considerably better, and that's also another factor which you can show reasonably well with the data has led the Earth to warm, because we've taken aerosols out of the atmosphere.
Uncomfortable irony that reducing air pollution can increase basically global warming in this case, climate change. Amanda, give me some examples of things you think are on the plausible end of the spectrum, maybe in the icy realm in which you dwell, if there are any there that you think would work.
So our project is looking at actually we're using Sean's sea ice thickening project as a case study to develop a framework that you would then go on to evaluate any of these things from an ecological perspective. And I think the biggest challenge with really deciding whether these things are plausible is a matter of scale.
Yeah.
So even from an ecological perspective, we can evaluate his small field parameters, but then when you scale up, it's a much bigger story.
I think it'd be really useful to the audience just to explain a bit how this works about pumping up seawater and spreading it. Just to go on, you can do it.
I'll let Sean correct me if I'm wrong.
Yeah, sure.
But essentially, it's like Sean said, using pumps that were borrowed from the oil industry to strengthen ice roads. Essentially, you're pumping seawater from below the ice up on top of the ice during the winter months.
And just give me a feeling of quantities. Are we talking sort of, pipes like a hose pipe in the garden, or are we talking about something?
It depends on. So there's a couple. He's working with a couple of groups that are looking at this. So one group can pump 600 liters per hour. The other group pumps about 30 liters per hour. So it depends on what kind of pump and the style that you do, and also the scale of how far you want to actually spread that.
Sure.
This is all part of the investigative stage. They're still very experimental, which is a good time, actually, in my opinion, to also look at the ecological stage before you start to consider, okay, we've got the mechanical side figured out. Let's scale up, but let's understand the ecological stage first.
But even on the mechanical side, you've got this huge question of how you power them, because obviously if they're fossil fuel powered, there's probably a zero sum or possibly a negative. But also, and I interrupted you before you got there, the actual scale of them, the number that you might need to make, and
perhaps that ends up being a prohibitory factor in utilizing that as a climate cooling effect. But maybe this technology...
Can I force you to put a number, the kind of order of the magnitude numbers we'll be talking about in order to have a climate effect?
So our models that we're doing for the ecological side, we're saying we really can't model below 1 million square kilometers. Now, thickening 1 million square kilometers of ice would be quite a logistical undertaking.
That feels like 1 million pumps to me.
Well, maybe. That's Sean's question to deal with, to be honest with you.
But it just gives the audience a feeling of quite how big
the scale is. But you've reframed the question. Perhaps what you're really trying to do, or what you could alternatively do using this technology and using the learnings, is restore some of the ecosystem services of that ice. So that's another reason why I think understanding the ecological impact of changing this, it's not typical for seawater to come up on top of the ice and freeze in the wintertime. That's not how ice is formed in the Arctic. So you are changing something physical about the natural processes in that region. But have you dramatically altered the ecosystem services of that ice? So, let's think about our favorite organisms, the polar bears. Have you maintained their capacity to survive in the Arctic by selectively thickening and maintaining ice in certain, pertinent areas of the Arctic? Perhaps that's a tool for the future. It might not be a global climate effect, but it's still worth investigating, and it's worth understanding, if you did use it in that capacity, what are the potential negative impacts of that from an ecological perspective.
And I know one of the points of this is actually how it could help the local Inuit with the issues they have on the ice. I'm not going to ignore that. I'm going to come back to it because I think it's the local, or I'll call them local benefits or collateral benefits are really important. Now, Clara, I know this you're not directly working on different technologies, but are there some that you think are are more plausible and some that are maybe more outlandish?
Yeah, even though I understand how hard it is on an engineering and ecological monitoring level, I think it's less of a technological problem than a societal one, because we have seen examples of technologies used on a large scale where people really weren't involved before. Even on a local scale, you know that if you don't have a framework in place to bring people from the start, things usually don't go really well.
Can you give me an example of what you're thinking of?
Yeah, it could be nuclear energy, for example. There's a case in Austria where they had already built the infrastructure, a nuclear power plant, and then they only asked citizens afterwards if they wanted nuclear energy, and they said no. And then you already have the infrastructure there in place that is that never got to be used.
That might not have been entirely accidental. I wonder if they only asked it later.
But they built the whole
fait
thing,
accompli.
and yeah, it's still there and not used.
Oh no, it's still it's not used. Right, okay.
No, yeah. There's only a festival that happens there every year now. But see, with geoengineering, if you do something on a global scale and you only ask people afterwards, then we're already in a really messy situation because you can't really undo it afterwards.
You are absolutely right to point out plausibility isn't just about the physical functions and the engineering issues. It's to do with acceptability and governance and politics, which is a good reason to come on to your neighbour. Okay. So what do you? I mean, I'm still keen, and if a few examples come up in this as well, I think it's useful for the audience. What do you think is sort of plausible and perhaps what's more outlandish?
So I think that's absolutely right from both of you, that to think about plausibility in terms of leverage and scale, right? The reason why people are thinking about this in the way that they're thinking about this is because this is a planetary scale problem. So people are looking for planetary scale effects. So I have a criticism of how the debate has been running in the sort of 21st century, at least, building on some very sort of Cold War-ish assumptions. There was this idea, especially with stratospheric particle injection, that putting particles in the upper atmosphere, that this was, to quote David Keith, who is one of the most enthusiastic, not proponents but discussants of this idea, that this was, in his words, cheap and easy, right? And we allowed this narrative of it being cheap and easy, right, that it would have a big effect and that we could do it for a few $1 billion, to continue without any real research into beyond just back of the envelope calculations. I think that's had a damaging effect on the debate on geoengineering and the debate on climate change, because it sort of dangles out this, it's a form of magical thinking, right? The idea that there is this doable intervention that, even though it would be messy, would have a dramatic cooling effect. And I think also people resisted doing the research to find out if that was true, because they didn't want to be seen to be associated with this idea that was dangerous to some people, at sometimes seen as unthinkable, because it would, according to our models, have all sorts of other undesirable effects. So I think the doability question is much more uncertain than we often appreciate. And there are so the other example I would just point to of an area where there was a huge amount of hype about a high leverage possibility for climate intervention was ocean iron fertilization, right? Which is not solar geoengineering. It's the idea that if you manage to fertilize a bit of the ocean,
just explain that a little bit to the audience. What is it you're spraying putting in the ocean? How would it have worked? Why does it help?
So the idea was that you would basically dump some iron filings in the ocean. These would act as a fertilizer to encourage the growth of algae, which would then sequester carbon dioxide, which would then fall to the bottom of the ocean. And that was the idea. There was a lot of enthusiasm about it. There was a famous unwise quote that one of the proponents of this idea issued at the time: "Give me a tanker of iron and I will give you an ice age." right?
And out that Amanda's written that quote down as well, saving it up.
There you go. And it's one of these ideas, right? Because it's a form of desperation that people wanted planetary scale, high leverage impacts. They wanted them to be cheap. And when people started doing research in this, they realized actually it's far more complicated in ecosystem terms, and let alone in engineering terms, in governance terms about how you do this. So I'm really skeptical of claims about the plausibility of these sort of high leverage interventions.
I've just remembered another one in the polar sphere, and that was this idea of putting a curtain around the sea around melting glaciers to stop the warm seawater getting underneath them. It's like a sheet around the Antarctic.
Yeah, so what I really hope will happen after we build our framework is that we will apply that framework to that concept. Because I think if you did that through an ecological perspective, you'd see quite a few negatives with that idea, to put it lightly.
The idea of this framework that we can then have an assessment that we can say, possibly, and frankly, if you bollocks, that's not going to.
Yeah, I mean, Sean has said this himself. A lot of the reason that we're doing this research is to potentially rule things out. And I think this could just be one of those tools to potentially rule things out.
I do want to talk about this. There was an announcement, I think, in the latter half of last year, a US-Israeli company called Stardust.
Can I just come back on the ocean iron fertilization? Because I think it's a really interesting example for some of the reasons that Jack said. But when Jim Martin said that about an oil tank of iron, he was actually coming at this from the point of view of ice ages. And so he was coming to this from the point of view of a much older school where geoengineering is a sort of thought experiment for thinking about the world. And he was saying that in the ice ages, more iron got into the Southern Ocean because there was a lot more continental shelf exposed in Patagonia and around the Falkland Islands. And that iron fertilized the ocean so that there was more carbon dioxide taken up by the algae, or by the cyanobacteria in the algae. And that led to depressed carbon dioxide levels. And so that was a plausible idea. And there was then a strange coming together of oceanographers who were really interested in that idea, and oceanographers who had an idea of applying that to geoengineering. And so and what happened in the process was that basically once the oceanographers interested in the past application of this had got what they wanted, they basically ditched it. And the geoengineering thing was not strong enough. But the other thing is, it did prove governance in that there was a fairly good international process for governing this, came up quite quickly and quite thoroughly. And so in terms of geoengineering not being good, not being able to be governed, OIF has in fact been governed really quite effectively.
Excellent. We'll come on to governance. What that strikes me as interesting about that is it shows the appetite for solutions. So you had something that was a bit of a historical thought experiment that was then picked up because we really want.
But as soon as the mainstream scientific bodies had decided that they knew what was going on, they dropped it like a hot potato. But they had basically, to my mind, to some extent, I don't know if there are any eminent oceanographers who are going to lynch me for this, but they kind of used the hype. They used the geoengineering story to get their really expensive ocean cruises to drop iron filings in the Southern Ocean. And once they'd done their research, they said, yeah, we won't, that's not really interesting. Okay. But they also found out that it's not an easy thing to do.
Okay. Amanda, you're shaking your head at part of that. What's it about?
What's interesting is my undergraduate and master's professor he called himself the grandchild of John Martin, because.
So better to say John. Was it John or James?
John.
So better who John Martin is.
He was an oceanographer, essentially a biological oceanographer. Okay. He called himself the grandchild of John Martin because his supervisors, etc. So this whole SOFEX iron fertilization thing is something that I kind of academically grew up with, and my specialty at Bass is actually phytoplankton ecology. So a lot of the reason that I'm not coming at you, by the way, Oliver, a lot of the reason that that SOFEX experiment, I would disagree with you that it was dropped. I think we learned a lot about carbon flux from that, and it expanded.
What is carbon flux?
So carbon flux, and one of the reasons that the idea of fertilizing the ocean is that you promote phytoplankton blooms, which are then consumed by zooplankton, which actually most of the carbon that sinks out of the surface ocean sinks through zooplankton poop.
The animal plankton, yeah.
Poop, for lack of a better description, you know. And so what happened in that is that it was revealed that we weren't promoting the correct type of phytoplankton. But it really revealed a very important understanding about oceanic carbon cycling, in that it really amplified that in the surface oceans, there's a lot more carbon cycling going on in the surface than we had fully appreciated. So that knowledge is critical
Okay.
for oceanic
Absolutely.
take up of carbon.
Okay, I do want to move on to this thing about this Stardust. So this is a US-Israeli company who've secured, I think it's around $70 million or something, to experiment with putting particles in the upper atmosphere. A mystery particle, they won't quite reveal what it is. It's sort of silvery and reflective. It does sound quite Bond villainy. But it seems to be, I mean, it caused quite a stir 6 months ago or so. Well, first of all, can anyone just explain it in greater detail for me?
Well, I can. This idea of putting aerosols into the upper atmosphere. So aerosols, again, little floaty particles.
Yep.
That's all it means. Into the upper atmosphere. It's been around for a long time. The assumption has been, and it's fluctuated, but there's been an assumption that you would do it as humans do it with pollutants and as volcanoes do it with eruptions, by putting sulfur dioxide into the upper atmosphere, where it forms little particles just on its own.
Dioxide.
Yes, yeah.
Oh.
And so there's been, and so as a sort of like second order question has always been, are there better particles? Sulfur dioxide is what we know already does this. So there have always been conversations about, well, is there something else, something better, etc. And then along comes Stardust, saying, we actually have a completely different particle which we won't tell you about, which we think will do particularly well here. We think that it's not toxic. I mean, the important thing about sulfur dioxide is that even about sulfates that are made from sulfate aerosols that are made from sulfur dioxide, the important thing to remember about them is that they do still hurt people. To put a little bit of sulfur dioxide into the upper atmosphere hurts people a lot less than putting tens of millions of tons of it into the lower atmosphere, which is what we do at the moment. But it's still a nasty thing. They claim that they have particles which have all or more of the advantages in terms of reflecting sunlight away that sulfate particles have, but have none of the health disadvantages. This looks to people in the field who I talk to as suspiciously free lunchy, you know, and especially when it comes with, we're people from the Israeli nuclear industry, trust us. That's not a good sell.
Yeah.
At the same time, they are saying that they have already distributed some of these particles with sort of like non-disclosure agreements to various labs in the world, and one of their financial backers has told me that they expect all the details of the particles to have been released by the end of this year. We shall see.
So they're actively doing it. I mean,
no, they're not actually actively doing it.
Sorry?
They're not actively doing it.
So these experiments are ground level. They're not actually.
No, they are giving particles to labs so that the labs can study them. They have not, I think. I mean, this is one of the problems. They are not the most forthcoming of companies. They have flown things, but quite what they've done on flying things is not clear. The fact that flying things in Israel means coordinating at the very least with the IDF is one of the reasons why many people think that they just don't want to talk about these people at all.
Thank you. Well, I mean, Clara, that brings us straight into sort of governance questions, doesn't it? I mean, you know, who gets to decide, who gets the impacts, you know, all these things. We've seen, even with a lot of it is conspiracy theory, but we've seen even with cloud seeding, it gets people, you know, furious. So I mean, the questions here are huge.
Yeah, I think Stardust is a very personal example for me, because trying to prevent companies like that from entering the field was why I first decided that I had to work with geoengineering 7 years ago, because it's the worst of all nightmares for me, I guess.
Okay, elaborate that. Why is that particularly nightmarish?
First of all, it's a for-profit company. even though they say they want the technology to be used by governments, it still got backed up by venture capital. So there is an expectation that the money will come back, and we know that's usually, well, selling a technology to a government, it's not necessarily ideal either. And it's not something you do just once and stop, right? If you have investors expecting you to have a project, they would want the profit to keep coming back and back. So you wouldn't do it just once and stop. And it's also not a technology that you can use it just once and let go of it. Also, the point, like Oliver said, that it's linked to the Israeli government, also their Ministry of Defense, that's really worrying. But also the fact that it's Silicon Valley money. So well, we're in a Trump administration, and then the combination of US and Israel doesn't sound really appealing to me. And the transparency issue, like you said, they've been.
Let's assume, just as a sort of thought experiment, let's assume it was a really benign, a super benign, benignia. I've just made up a country, who was doing this, and it was being publicly funded, etc., etc. There would still be questions, wouldn't there, about what impact it's going to have on what country and all these
Yeah, of
things.
course, but then they would be transparent about what their substance is, and they would have been engaging with people, and that's not what they're doing.
Right. And Jack, I mean, the governance is absolutely up your street. I mean, this issue of if you change the weather, I mean, it clearly doesn't stay in one country, so you've got a massive problem from the get-go, haven't you?
I mean, that's the immediate and sort of obvious governance question that's raised with especially these sort of high leverage proposals, especially with stratospheric particle injection, where the mode of intervention has to also, it's not just that the effects will cross boundaries, because in effect you're going for an uncontained planetary scale effect, but also the mode of intervention, right? The particles will disperse across all sorts of places. Raising international relations questions, obviously, and until I think, I mean, maybe I'm being naive, but maybe a decade ago, we were sort of all assuming that these sorts of ideas sort of probably would be worked out, if not by governments, then through publicly funded research programs.
Governance would have been done first before we.
No, sorry. The research and development of the things would have been done simply because at the time we couldn't envisage what the economics would look like that would give a startup the incentives to do something like this, right? There were clear economics with something like carbon capture because there were carbon markets and all the rest of it. We had some sort of scenarios that, a rogue philanthropist might try and do this as a sort of act of that they regarded as doing it in the public good. I think part of the worry with this startup is a lack of transparency, not just about what they're doing, but why. And this is a fairly conventional question that we ask of a lot of Silicon Valley activities. We don't know the business model, and maybe they don't know the business model. Maybe that comes later. But if we're going to start to, hold these things to account, we need to sort of get a sense of what the process of scaling and selling this stuff might be.
It strikes me though that I said $70 million if it was a lot of money. Actually, it's tiny amount of money in comparison. If you actually wanted to make this any of these things a realistic prospect, you're talking. I mean, someone once said to me, when you're talking about climate repair, you need something on the scale of what's damaging it. So you need something on the scale of the fossil fuel.
So I think it's an enormous amount of money
trillions.
In terms of the precedents that it might set, right? It's clearly not an enormous amount of money in terms of the impact that it might have on the environment.
Mm. Yeah. Sorry, Clara, and then.
For one single project, right? Because we have the ARIA program here in the UK, but then it's distributing the money.
Funding.
Exactly.
Yeah. Sorry.
I just want to say, I think that's an important distinction there between carbon dioxide removal and solar geoengineering. It's certainly true that if you want to remove carbon dioxide on a scale similar to that which we put it in, you need something that's basically like the fossil fuel industry in reverse. You need something on that scale. Solar geoengineering has a huge amount of leverage. You can counteract the effects of many billions of tons of carbon dioxide in principle with a few million tons of sulfur dioxide.
So do you think done right, it's plausible technically?
What do you mean? I think privileging the technical when you talk about plausibility is part of the problem. I think saying that it,
Okay, could you envisage a scenario where there was the technology and the governance to get this right?
Yes.
Okay.
I can envisage that, but I can envisage a colony on the moon too, and it doesn't mean I'm about to build one. But I wanted to come back on something that, because we're talking about transparency, and something that's been slightly bugging me, is that I don't feel that we've had the opportunity for transparency. I'm a journalist and I'm a writer. I wrote a book about this, indeed, which has a scenario in which it goes all right, which was actually oddly physically difficult to write. It was hard to force myself to write that scenario.
Why?
Even because we are so used to looking at the fact that it might go terribly wrong, which it might.
Yeah.
It was genuinely actually hard to write that. I can, but you know, problems writers have, not a big one. But I'm also a volunteer. I'm the chair of the trustees of an NGO which funds geoengineering research in the global south. We do this because partly because people in the global south have questions about solar geoengineering that don't get answered by researchers in the global north. But the more important part of why we do it is that when there are discussions, global discussions on governance, the global south has trusted, engaged, confident experts in this area to whom they can turn. Because at the moment the knowledge is very much centered in the global north. And the point I was making, so I am the chair of that organization called Degrees, and and some of our funding comes from Silicon Valley, because Silicon Valley is very interested in this. The same is true for DSG, which is an organization, in fact we share some funders, an organization that Clara works with, called the Alliance for Just Deliberation on Solar Geoengineering, which also has a focus on the global south and is an excellent organization. But again, it is, we share some funders in California.
Okay.
So I think you needed to know that.
And just on that global south point, I think it's worth repeating a remark that actually Sean told me on our podcast and radio show, that actually you had a lot of people from the low-lying countries, Tuvalu and etc., who are very interested in this technology. So it's not solely a sort of or Western or Silicon Valley fantasy, is it? A lot, they are interested in climate repair.
There is increasing interest with various members of the Climate Vulnerable Forum specifically.
Before we leave governance, the questions aren't solely limited to what we might do with the atmosphere, and this would be true in the oceans as well, wouldn't it? I mean, they're particularly the high seas, as they're called, are relatively. I mean, I know there's a UN convention about it, but once again, it's difficult, isn't it?
And I think there's some groups like ICES, which is mostly based in the Arctic, that are trying to, and there's discussions in the Arctic Council, they're trying to come up with some kind of collective voice and discussion on that, and an opinion on governing geoengineering in the regions. SCAR, which is the Southern Ocean Agreement and the treaty, the Antarctic Treaty, it's the goodwill of everybody that's in the treaty. There's nothing actually legally binding. They can all agree that maybe this is not the best way forward, but they can't stop one individual country from doing experiments should they choose to do so. So governance is a challenge, and I think Antarctica is a great example of a place that no one country controls it, but lots of countries are involved in that treaty. So getting consensus on something like this is even in the Southern Ocean, where we don't have local communities that also should have a voice.
Well, I was about to come
like,
to local.
It's a relatively simple task because you're not involving human lives in the same way that you would be in the Arctic, and even that is incredibly challenging.
Because I said I'd come back to local communities with relation to your ice thickening thing, but part of that is to do with the Inuit saying that the caribou were falling through the ice, or maybe they were falling through the ice as well, but they were actually interested because it would strengthen the territory where they're caribou.
Yeah, so that's a prime example of how perhaps this technology could be used as a ecosystem service. Which what I mean by that is, like you said, caribou routes, or maintaining fishing grounds, ice fishing grounds a little bit longer. So it might not have the climate impact, but it's worth looking at from that perspective, but then there's potential benefits otherwise.
Yeah. Clara, I'm guessing some of these local community impacts will come into your sphere in terms of the justice of this.
Yeah, and there are so many layers to talk about this, but I guess if we think about the Arctic, for example, is not just about animals, but also indigenous communities that have historically been marginalized when it comes to decision making in the region. But then thinking about young people and future generations who will be somehow locked in to these technologies if they're ever used. So yeah, there are lots of layers, but I think that it's more dangerous not talking about it than doing so, because then if you don't talk about it, you're just opening space for people who don't necessarily share those justice and fairness values to take over the field.
Yeah, and we've seen with recent pushback, arguably, and environment getting itself on the wrong side of an anti-establishment backlash, is a lot of people see these things as imperatives from above over which they have no control, and you know that would definitely, or risks definitely being the case with this, doesn't it?
The one additional concern that I think we should have, I think, these initiatives to engage communities, especially communities that have been historically shut out of not just environmental decision making, but decision making about large technological systems. They're so important. There is a danger that those communities get instrumentalized by people that want to do a particular thing.
What do you mean instrumentalized?
In that, the benefits to a particular local community, the promises that are made to that local community are then used as justification for a particular intervention.
Yeah.
Or, for example, the views of people in island states are used as a way to legitimize particular things, which might, they might be decisions that most people agree with, but there is some crucial differences between engaging local communities in decisions that are affecting them and then using those voices for other reasons.
Jack, I wanted to ask you a little bit more about funding, because we've been skeptical about some of the sources of funding, Silicon Valley, etc. You've got, I think I read you got funding in your title. Where is a good source of funding for this? Because if you're going to say governments, then I'd like you to see you justify it in an election, that the taxpayers' money is going to go there.
Yeah, absolutely. I mean, in as much as I've sort of come down on a funding position, I have been arguing that actually we should have relatively small levels of funding. Some people have said this is a big problem. We need a sort of Manhattan Project style government initiative, especially if we're worried about the private sector. I see a case for what I've called slow science, which is sort of heretical, especially in a place like Cambridge University.
Well, and especially facing the climate crisis.
Yeah, absolutely. Right. It's quite a hard argument to make. I mean, I'm currently involved with ARIA, the funder that's supporting some of the work here. I was really ambivalent about getting involved in that, because that is a big chunk of public money being spent on what they are calling climate cooling, and a few of us had long conversations with them before they announced this program about did they know quite how contentious the area was, that it reached far beyond just science and engineering to include these questions of democracy and governance and ethics and all the rest. I don't know how that process is going to play out, but I have been really pleased how, as an experiment in funding, it's not just that government are funding, it's how they're funding that I think is really interesting, right? That they're forcing projects to be transparent. They're forcing projects to go out and talk to their local communities who are being affected. They're forcing projects to talk to each other, so that it's not just that mode that quite often we see of sort of fire and forget, go away, do your experiments, and then tell us how great they are.
Yeah.
Yeah, I mean, I can see why you have difficulty selling slow science in the Babbage Lecture Theatre. I can also see why you might have a difficulty. I've been writing about solar geoengineering on and off for 20 years. During that time, a third of all human cumulative carbon dioxide emissions have been made. and not only because I don't think I have another 20 years, but I think that that the rate of progress has not been disturbingly fast, or the rate of change has not been disturbingly fast. The other thing is that, as you were talking earlier about the lack of real understanding of how this might technically be done, but you're also a signatory of the non-use agreement, which says that there shouldn't be public research into how it should technically be done. And so I don't understand how you square those positions. If you want that knowledge, but you don't want the public to do it, but you do think the public should be funding this, I don't see where that works out.
Yeah, the non-use agreement has some.
Could you explain the non-use agreement?
There's
one of you.
Yeah.
Sorry.
You should.
Yeah.
You're a signatory. I'm not.
As a signatory, so this was an initiative. I'm trying to remember how long ago, maybe sort of 7 or 8 years ago, to bring together some concerned, mostly academic voices, to a sort of consensus document to say we don't think solar geoengineering is safe. We don't think it's ethical. We don't think it can be governed democratically. And there were also some statements in there about research towards it that said things like, we don't think that outdoor experiments are a good idea. Now, there's lots of debate about what we can count as an outdoor experiment. I mean, my own view is that most outdoor experiments that people wanted to do that were actually designed to test the feasibility of a system in terms of, can we know that this is having a climate impact, that would be premature, yeah. Right? But there's lots of work that we could do feasibility.
Well, that sounds like a fairly tight shutdown you signed up to.
Sorry?
That sounds like a fairly tight shutdown you signed up to.
It was polemic in the sense of wanting a clear statement that people should not be advocating use of this technology.
Yeah. Well, it's also
I still think there's lots you could do that research the feasibility and desirability of it.
Briefly, Oliver.
A bit beyond that, because it does say that government shouldn't do it. It doesn't say that they should research and then decide. It says they shouldn't do it.
Yeah.
And so I think I think it's wrong to say that it says that research should be careful, and it does say that this should not be deployed.
Okay, just briefly come back on that, Jack, and then I'll move on.
Yeah. So, I absolutely agree that, as I've said though, the trouble is that we don't have a thing that could be deployed, right?
Yes, but it says we shouldn't do research to make a thing that could be deployed, and it also says it says quite specifically, if anyone else does that research, we shouldn't deploy it.
Yeah.
And
okay,
so that's a fairly tight, as Tom says, it's a pretty tight constraint.
I'm going to park it there. We can the audience can take that up if they wish. Clara, I just want to explore justice a bit more, because I feel I haven't given you this. What are the kind of justice? We've explored some of them in terms of sort of international governance and maybe who's paying for it. What are some other justice things I've missed that you're concerned about?
I guess climate justice is a very broad topic, right? But when even thinking about the non-user agreement now, I think there's a huge problem when you have a group of academics, mostly from the global north, saying that we shouldn't research, shouldn't do research on this, because what if citizens actually want research, especially the most climate vulnerable ones? Yeah. So this would be a climate justice issue, for example. But then, like I briefly mentioned, intergenerational justice. Are we involving young people in this? If it's something that's not going to happen only now in 2026 and that's it. But you can also think about justice, environmental justice. If these technologies are the last resort to prevent the Arctic from melting or the coral reefs from bleaching, then there's also a tension in there.
I'm wondering, Amanda, whether we're in it. It's very easy, it's a very complex world, and this is a very bold, let's call it, and complicated idea. Are we sort of concentrating too much on the negatives by expecting everything to be perfect, when maybe there are actually things we could be getting on and doing that are, as I say, sort of more doable, but rather than by concentrating on the outlandish and the really tricky and the ones that have funded by the Israelis, who are currently, a difficult group to work with. Are we ignoring the fact that some of the things, and these may be more basic things like extensive bamboo planting, or rock dust, or some of these other things that we're ignoring?
I think we're at the stage in this discussion that we need to be a little bit more pragmatic about the tools that we're using to assess whether those things should go forward or not. So that's why we've said we need a framework for the ecological assessment. I think there's a really good cause for a kind of a step-by-step framework on developing a governance plan for a project. I think we need to move past the should we, shouldn't we, and get into that, okay, let's assume that we are researching this. Now, let's put some tools forward to make it the most transparent, potentially just, way forward, and garner the evidence to make that decision. Because right now we can't really make any call because we don't have enough evidence for any one particular plan, particular project or idea. So we need to move past the should we consider these ideas and move into the let's develop frameworks or processes that help us to really get the evidence to make that decision. So that's what our project is. I mean, I said I'm working on evaluating Sean's project, but only as a case study. It's to the broader point is this framework can then be used by anybody who wants to then ask that question, should we do this, yes or no? From an ecological perspective, you go through these steps and you get an understanding of the risks associated with it before you can make that decision.
Okay. I do worry a lot about the moral hazard, the idea that once you've backed it as a plausible, then from that moment on, you do let people off the hook. The kind of example I'd give with this is actually carbon capture and storage in industry, which is actually plausible. It can work, but they haven't put any kind of money into it in any of the scale that would actually make it work. But as a result of it being on the table, then we've had all this nonsense about clean coal and clean hydrogen, and the word clean gets attached to a whole bunch of things because it is technically possible.
Yeah, but I think just because something's technically possible doesn't mean it's ecologically
indeed not
moral.
But it becomes
so that's what
politically acceptable.
Yeah. So that's why you need all of these aspects. So the way I'm kind of considering it is before you determine whether a geoengineering concept should go forward, there's multiple pillars that you have to rectify. One of them is ecological, one of them is governance, one of them is social impacts. And until you've rectified all of those pillars, you really don't have all the evidence you need.
What a series of filters to get through, isn't it?
It's quite, and that's, I mean, forget about the scale question. It's a very complicated thing, and it's almost as challenging as decarbonization. So it's not a quick fix. And I think in that respect, it's also not a hype, because it when you get down to the nitty gritty, it requires quite a lot of investigation.
Yeah, I'm going to open it up soon. But just
about your point about carbon capture and the imagination. The clearer example of this isn't actually in the area of solar geoengineering. It's in the area of taking carbon dioxide out of the atmosphere, because academics told governments that if they were able to do this, they could have a 1.5 limit, because you can, in theory, in a model, or you could at the time of Paris in 2016, just about keep the climate below 1.5 if you assumed you were going to have this new technology for taking carbon dioxide out of the atmosphere, direct air capture or rock dust or whatever. And so the entire thing was based on this idea that there'd be a technology that there isn't and still isn't. And so we're now in a situation where we're now in a situation where effectively we are now this is why it is. It's sometimes difficult to say these things. We're not going to keep the climate, but the climate is not going to stay below 1.5. There is no plausible set of actions or even implausible set of actions that's going to make that happen. But we, as citizens of the world, signed up in Paris to saying that might be possible, and that was done on the basis of a technological promise which no one really had any intention of keeping.
Can I just add? So I think this it shows you something really dangerous about technological hype. So in that at Paris, for example, you had the world's best climate scientists coming together and agonizing about the numbers, about climate predictions. But when it came to the gap between what policymakers wanted and what the scientists told them was achievable, it was filled with what I would regard as sort of magical thinking about technology, that even though you had this hardcore science as the basis of the decision making, the magical thinking then sort of becomes self-fulfilling in quite a dangerous way. And I really worry about this with other suggested modes of climate repair as well, especially given all of the efforts that scientists have made to elucidate the climate problem itself.
Okay, we need to get this out to the audience. Just there's a mic up there. Just a little bit of question and answer etiquette. If you could keep your questions fairly punchy, more like a I was going to say a tweet. That's not so political anymore. More like a blue sky than a rambling email. That would be great. I mean, if you've got a succinct point to make as a statement, that's good. But a question is always good. And if you can direct it to more towards one member of the panel, otherwise I'll do the same, because I don't want all four to answer every question. And with the answers too, if you could keep them fairly punchy, that would be lovely. Who's going to start us off? I can see it. Yes, you sir, you've got a mic right there. And if your name is important, feel free to tell us. If it's not, don't bother.
Is this on?
Yep.
Yes, it is. Good.
Nice and close to you.
Yes, my name is Robert Chris. I am an associate of the Centre for Climate Repair here, amongst other things. I just want to make one very quick point. The non-use agreement was not 7 or 8 years ago. It was actually 2022. There's a very lovely picture of you, Jack. I have to say, clean
with
shaven.
a beard? No, without a right.
Clean shaven on the internet. 2022. It's quite recent, and there are a lot of signatories. So what I wanted just to bring out was I wanted to just question the framing for this whole discourse, because where this whole conversation has come from this evening and routinely around geoengineering and climate repair is that it's an option. In other words, this isn't the case of we have to do this, let's make it as safe as we possibly can. It's if we can make it safe, then we should do it. And the implication is that if we can't make it safe, we won't do it, but we'll still be okay because the not doing it is not that bad.
And your view is that it's not an option? That it's
well,
essential
my view is that the climate models all tell us that, as has been made point from the floor this evening, that there are no plausible options now that are based simply on managing the carbon cycle, whether it is reducing emissions or removing greenhouse gases from the atmosphere. There are no plausible options that will prevent us from reaching 3 degrees by mid-century.
We have to find a way to make it work.
So we have to. So the argument is, why are we talking in these terms? The argument should be, we have to make this work.
Thank you. Amanda.
I think, thank you, Rob, for that question. I think that's even more of a reason why we need to have thorough understanding of their potential negative impacts. Understand those risks. Maybe it's a very improbable risk or improbable consequence, but with a massive, risk to it. You could maybe change your mechanisms to mitigate for that. But until you actually do the science and understand the ecological impacts of these things, you don't know what those risks are. You don't know. And then once you have those risks, you can put it to society. Maybe today we're not ready to accept those risks, but maybe down the line we will be.
Well, no, until you start doing it.
Okay. So,
to a certain degree, maybe.
This gets to one thing I find very difficult about this discourse, is this idea that there's some sort of global we that makes these decisions. I think it's quite likely that some group will try it. I think it's also possible that they won't. But when you talk about options, I think most of us would agree that the option of not having a nuclear war is a good option. And might want to go as far as say that that's the only thing that's really possible. However, nuclear war is possible, and a huge amount of climate change without any attempt to deploy these technologies is also possible. It's not the case that it's necessary. I mean, you may feel it morally necessary, but it's not the case that humankind will necessarily do it any more than it's the case that humankind will necessarily avoid a nuclear war.
Thank you. Yes, you've got the mic, I believe. Yeah.
On slow science, are we making perfect the enemy of the good? So is it worth thinking about another example in health, for example? So public health, where sometimes we have to do very large clinical trials to know the answer. So, for example, I'm doing a 120,000 patient trial to see if we can screen for esophageal cancer, right? It's within an ethical framework. There's consent. It may, I hope, do good. It may also do some harm. But unless we do that large-scale experiment, we'll never know. And I could do as much slow science as I like to try and make it, in a lab absolutely perfect. Until I do the big experiment, I won't know.
Okay, so a little bit of risk is worth it to find out the result. Jack?
Yeah, I mean, I think clinical trials are a really interesting example, right? And there are occasionally biomedical researchers who would like those to be a lot faster. But I think most of us would recognize that there are reasons why that process has evolved in the way that it has, and involves others, it involves stakeholders, it involves going slowly and safely, because there's a lot at
You have
stake
to make
there.
the leap at some point. That's
Yeah.
the point.
Yeah, I think so.
So when do we
But-
have to make the leap on climate repair?
Yeah, I mean, I'm putting out a sort of counter position, because I see lots of pressures. As with the previous question, we need to. There's a lot of pressures towards doing it without much working out of what the it is, right? And actually, I still think it's worth us. I think it's worth just enjoying the potential for slowness as a virtue, to do this thoughtfully, given what we think might be at stake for doing it recklessly.
Okay, not Sean yet. Yes,
Yeah, I just wanted to ask, without a real appetite to reduce carbon emissions, I mean, we've heard everything coming out of the Trump administration.
sorry, a little bit louder if you could, please.
We've heard everything coming out of the Trump administration. China's bringing online 95 gigawatts of new coal-fired power station capacity. India's emissions have increased from last year 1.7%. Without a real appetite to reduce carbon emissions, isn't this just all hype? Because most of these climate repair initiatives are not going to be sustainable. I mean, there's only so much aerosol, even the safest aerosols that you can inject in the stratosphere. There's only so much water you can pump from beneath the Arctic.
I actually don't quite share your view of either China or India, but particularly China's direction of travel on energy. But we'll park that thought. The general's point overall was, look, is there any point in doing this when we're not sufficiently cutting CO2, Clara?
Yeah, I
And other
agree.
greenhouse gases.
I agree with you. We need to do a lot more, but we also have to be realistic. We already know, even if we cut all emissions today, there's still a residual increase. And that might be the end, like I said, for the Arctic or for corals, or for some communities that will suffer a lot with heat waves that we can't really control anymore. So I agree with you. There is a lot of work that has to be done in mitigation, but it doesn't mean that we will do mitigation first and then try to solve these other problems that will come whether we like it or not.
Isn't it an example of, with climate, so often it's not a question of either or, it's and. We clearly need to be reducing the greenhouse gas emissions, but it doesn't necessarily prevent us from going down this road as well.
Ideally, we wouldn't need to be having this conversation now, but it's just because, things are not working. But it doesn't mean that they should continue not working. I guess we just need to ramp up really fast now.
Just briefly, if you could, Ola.
Well, I was just saying, it goes to a point that Jack was making earlier as well. I think there's no doubt that serious discussion of solar geoengineering will reduce some of the incentives towards carbon dioxide reduction, emissions reduction, and that's something that I worry about a lot. However, I also think it's the case that even in the absence of that serious research, you will put the moral hazard, the sense that because geoengineering might be possible, we don't have to mitigate so much. That idea is already out there. And I think there's an argument from Stephen Gardner's book, A Perfect Moral Storm, which he doesn't, I think, would not apply this way, but I do, which is arm the future. If the worst thing we can do is go slow on emissions reduction because we've got this vague feeling that geoengineering is possible, and at the same time not do the research on geoengineering that would show whether that's true or not, because then we don't do anything to reduce the risk and we hand on the harm.
Worst of both worlds.
Exactly.
Yeah. Sure.
I just thought it might be helpful. I'm going to just read the opening stanza of the non-use agreement. The International Non-Use Agreement on Solar Geoengineering should commit governments to 5 core prohibitions and measures. 1. The commitment to prohibit their national funding agencies from supporting the development of technologies for solar geoengineering domestically and through international institutions. Number 2, the commitment to ban outdoor experiments of solar geoengineering technologies in areas under their jurisdiction. We heard this evening from Amanda saying about the need for an evidence base. And actually, Jack, you shared with us actually about how research is done having changed. So if you were asked to sign the non-use agreement today, which is different from where we were 4 years ago, would you sign it?
Yes, so I still agree with those ideas. I interpret outdoor experiments, though, maybe more broadly than some in this audience would. Or no, I interpret outdoor experiments to be large scale sort of intervention perturbative type things, not just testing a technology outside. And I agree that that governments shouldn't fund the development of the technology, but they urgently need to know if the technology works or not.
I was confused about that, because didn't we see a headline about how we're the biggest funders of solar geoengineering around the world? How does that fit with point 1 that you just read out? Anybody?
That's for the panel to answer, not me.
Yeah. Does that, how come those two things square? Point 1 that he read out about not funding this stuff, and the fact that we are
point 1 about not using the stuff.
No, it was about funding development. And it's therefore the interpretation of the words development of technologies. How are you interpreting those? I think.
Yeah. So I interpret that in a sort of Manhattan Project style. We want to build a thing, right? I think a lot of the research that ARIA is funding is about testing.
So it's a question whether the research base is the same as development.
Yeah.
Very.
But there is a really interesting, a question about how the geoengineering debate has changed as the climate has changed. The climate debate has changed in the last decade, and raised by the previous point. That sense of growing despair that an earlier climate consensus, that the sort of thing that those of us that worry about, I don't like the phrase moral hazard, but let's use it. We were worried that climate consensus looked really fragile, and that holding out the hope of this technological fix would make it crumble. And now it's just very, very clear that the climate as a priority has fallen so far down people's lists. And I think it does change. It does, I think it changes the character of that debate about technological fixes and febrile climate politics.
Okay, we must crack on. We've got lots of hands beginning to go up. So yes, nice and punchy with the question and the answer, please.
So we've spoken a lot about there needs to be governance, but I think I still have a lot of questions about exactly how that can look, particularly when profit is involved, and generally climate governance is known for being quite slow moving, and some would argue has been relatively ineffectual. So yeah, I'm just interested in tangible ideas for how that can work, or guardrails that can be put in place if it is something that we need to do. Can governance move quickly enough alongside the technology?
Clara, what would your perfect governance regime look like? And that's in 2 or 3 sentences, not a book.
I will link that with something I wanted to say about the non-use agreement as well. Now as an academic doing my PhD, I wouldn't sign the agreement, but from several academics that I've talked about who have, I can clearly see that we share the same set of fears and values, but we just take different approaches in how to deal with the problem. But a big flaw that I see in the agreement is that you're still relying on the existing governance frameworks. And maybe that comes from, I don't know, trauma, that you've seen so many bad things happening and you don't want to happen again. But if you're saying you want to ban this type of technology, you still need to get all countries together in the same room. And like you said, that's very slow and it might not work. So,
but what would the guiding principles of a governance regime be that would enable just use of climate repair?
Ideally, we need something that goes beyond national sovereignty. And we only have a couple of examples, and you mentioned the high seas. We've just recently signed the High Seas Treaty, and that could be a great example of
we being who?
we as in like countries.
But a very large country has.
Yeah, the US.
Yes, so it's flawed. We
Yeah.
need something else where national sovereignty really isn't there on the table, and that
The
we have
Antarctic
never
Treaty,
seen
is the
before.
Antarctic Treaty a
Yeah, but not all countries are part
Indeed.
of it.
And could I also, just in response to your question, I mean, it's definitely not an answer, but there have been arguments that, I think we should take seriously that the technologies proposed for solar geoengineering, particularly stratospheric aerosol injection, look essentially ungovernable. And that might be one reason for taking them off the table, right? So that would be the argument of somebody like Mike Hume, for example. Now, I think that presumes too much about what that technology looks like, and I don't think we know what that technology looks like. But I think we should, take seriously that, because we mustn't kid ourselves that we can just, a little bit of this and that, right? Maybe this is.
Thank you. I want to crack through some questions. So, yes?
My name's Athena. I work with Amanda at the British Antarctic Survey, and I'm going to pivot into a slightly different area. I work with environmental scientists who, in the mainstream, are keen for decarbonisation. However, they are very open to polar geoengineering. However, what I have observed is a real division amongst our scientists, and I think it's really important for them to stay on the same side. How do we make sure that happens? Because division is everywhere in our life at the moment about whether we should pursue polar geoengineering or whether we shouldn't.
Amanda would like to. The question says we need to heal the division. I'm not sure if that's the case. I mean, people are going to differ, aren't they? According to how you deal with the narrative.
I actually think a healthy debate and discourse is important. But I also, as Athena said, colleagues within BAS vehemently disagree with even my project existing because it's taking public funds that could potentially go towards something like, renewable energy and things that they would consider more green. So I absolutely understand that perspective, but I also recognize, we've talked about it already. You mentioned it, the Stardust. These things are going forward. There is investment in this by perhaps groups that we don't necessarily want investing in it. So I think we need to take the opportunities now to create the frameworks, the protocols, the governance, to make sure that it's done in an ethical way.
I think one of the reasons that there is such division of this is it's the narrative thing. It's something that Oliver mentioned earlier when he was talking about the difficulty of writing it. There are two we're very much a narrative species, and there are two kind of narratives. We like the narrative of innovation and change and solution. That's a narrative we like. We also like the narrative of sort of fear and overreach and Icarus flying close to the sun. So these are almost two competing narratives.
I don't think it's a bad thing to play devil's advocate with even within myself, even within my team. We constantly play devil's advocate about is this the right path to go? Are we remaining independent enough to have a critical evaluation of a geoengineering project? So it's not a bad thing, and I don't think it should be completely squashed, but at the end of the day, we do still have to move forward with ideas.
Okay, thank you. Yeah.
So my question is about the negative impacts that these strategies can have, because obviously we are thinking that it's dangerous and controversial, and these are some of the opinions, because if we start using these strategies, there's no way to reverse the effects. And as was mentioned previously with the strategy where we make the ice thicker, it doesn't really, if it doesn't work, it doesn't really have doesn't really affect the way the ecosystem is able to function. But are there any more serious negative impacts that we should be thinking about with these strategies?
Are there more negative impacts we need to worry about?
I think the worst negative impact for stratospheric solar geoengineering is the impact on mitigation. I think the evidence, I am actually, and I do worry about this because I think it would also be what one would expect from groupthink. But I think that there are arguments that you can make some types of scenario for future use that don't have strong biogeophysical side effects. They do have them, but you cannot assure that but you can't assure that your scenario is the one that wins out. So once this starts happening, it's going to happen in a bad and mal-governed way. There will be governance. There are already organs for governance. There is, in fact, already governance through the Convention on Biological Diversity. It's very, very weak. But I think that the problem is that this is not an easily governed, or in fact, I don't think plausibly fully governed way of doing things, and that's where the risks are. Because I was going to say, there are ways of doing this in which I think the adverse effects from what we know at the moment on what you might say the natural, the planetary side of things are moderately, are less than the risks of unmitigated climate change. But I don't think we have a way of getting to the scenario where you only get the good version.
But I mean, a good example of harms, unintended consequences. If you plant trees in the wrong place, and we've seen that happening a lot when you make them carbon sticks and you put a lot of money in their direction.
Oh well, if you plant trees anywhere north of here, you're warming the planet anyway. You're not cooling it.
Just sort of reflective. But you plant them over savannas and you put eucalyptus there and it all burns. I mean, there's a lot of negatives there. Yes. No, I think there was one over here as well. Yes, sir.
Thanks. It's Andrew Harmsworth. I'm a physics teacher here in Cambridge down the road, and I also deliver on sustainability. So I talk to hundreds of pupils every single year about this. And when I grew up as a teenager in the 80s, we had a lot of hope and hype about technologies, particularly in physics, one of which was nuclear fusion. And the pupils say to me today and ask, what's the most likely thing that's going to happen in the next 5, 10, 20 years? So I've been teaching physics here 27 years, and I wondered, in 24 years when we get to 2050, and yes, it's closer now than the year 2000, what's most likely? That we'll have started to deploy a climate repair, or we've got nuclear fusion?
The panel may not be expert on nuclear fusion, but what's the most likely that we'll have got to by 2050, Clara? Will we have it in any meaningful sense, more than just going out to plant a tree in your garden?
I fear that unilateral deployment of one of the geoengineering technologies might happen.
Okay.
Yeah.
And Jack?
I don't do predictions.
Do you do suggestions?
I mean, I do think, in terms of climate repair, I think there will be lots and lots of different initiatives that we might, only some of which we would recognise as climate repair.
Okay, I want to give the rest of the panel because I'm afraid
I'll say I'm quite with Clara on this, as on many things. I think that there will be attempts by some actors to do some things that we would definitely see as part of the subject we're discussing today. I think there will be some nuclear fusion. I don't think it will be a large part of the energy infrastructure, but there will be some nuclear fusion. I also think that photovoltaic cells will be ludicrously cheap. I mean, ludicrously cheap by 2050.
And that is a whole nother story, which I love. But yes, Amanda.
I think if we continue to have the discussions now about getting the evidence right, I think there's a strong possibility about 2050 we have some options that are potentially feasible. I think we don't have the time to dawdle, unfortunately.
Okay, I knew the cicada's calling at the back of the room. So I was told we've got to be out here bang on 8. I'm sorry, I cannot take another one. I'm sorry, sir. If you have a chance to speak to the panel at the end, that would be great. I do apologise, because I was told I need to be out by 8:30, and I want to see. Let's just do the Slido question again at the end, if we can quickly bring that up and see if we've changed our opinions on hope or hype. I think it's possibly always easier in these panels to highlight the problems rather than the opportunities, but let's see how we go. So if you could do your Slido thing again, and let's wait for just 30 seconds just to see whether we've changed. Previously, well, actually, I'm not going to give you you may all have written down the figures earlier, but I don't want to bias the sample by telling you the figures earlier yet. Okay. So, okay. Oh, yeah. I can see that. I think we've got 30 seconds to get out of the room, so I better hold it there. When we started, it was Hope 48, Too Soon 27, and Hype 20. Sorry, did I get that right? Yes, I think that's right. So it seems to me that there is an increase in the proportion who think it's hype, and a slight decrease in the proportion of people who think it's hope. As they say, not scientific, merely a bit of fun. And I do hope you had some fun here this evening. Thank you very much for coming along and asking such smart questions, and particularly thank you to the panel for a really, really erudite and entertaining discussion here. So please put your hands together for the panel and for Sean. And I don't think there's anything else I've forgotten to say, is there? No, very good. Have a great evening from here on.